For the first lesson in our equations and inequalities unit, we'll be talking about combining like terms. And this is the same as in real life when you're counting up objects. You would combine or group together like items. For example, here, there's these movie boards, and there are 4 of them. And then the rest of them are popcorn, but I would not count them together because they're not the same thing. So these ones are popcorn, and there are 14 of them. I couldn't say, oh, popcorn plus movie boards, total, there's 18 popcorns, or 18 popcorn movie boards. It doesn't really make any sense. They stay separated in their 2 groups. Like terms can be combined in a similar manner. A term is considered like if it has the same variable or variables with the same exponent or exponents, depending on how many variables you have. Constants can also be combined with each other. And remember, constants are just numbers without variables when you see them in an expression or now an equation. Okay, so let's practice combining like terms. I'm going to use some different colors on here so that it's easy to see. You can also use different shapes to kind of box them in. So, for example, here's 7x. 7x is going to match with anything that has the same variable and the same exponents. So 4x matches, 5x matches, but I can't say x squared matches because it has the squared, whereas these ones do not. So that x squared is its own thing, and I don't actually see anything that matches with it. Okay, the 13y, that's going to match with the 12y and the 15y. There's also the 9y here. And then last we have the constants. So 1, 24, 15, 3, and 8. Just plain old numbers. Oh, and it looks like we missed over here one of our x terms. So that's all the matches. And we're just going to skip that little part right there and move on to the examples. So in number 1, what we're going to do is use this idea of combining like terms to simplify our expression, meaning make it the fewest number of terms possible, the shortest we can possibly make it. It might not become one single number, but we can try to get as close as we can. So 6 times x plus 12 times x plus 3 times y. So I have 6x, or 6 times x, plus the 12x, but then it's plus a 3 times a y. Since it's a times y versus the other 2 being times x, I didn't group them in the same color. Those x's can be combined. It's as simple as just adding up the coefficients. So 6 and 12 is 18. Attach that x back on, plus 3y. But what's really happening here, and I'm just going to show this a couple of times, the 6 times the x and the 12 times the x are like a shorthand for addition, right? So 6 times x means add x 6 times. And then plus 12 times x means add another 12 x's onto that, and you'd get a total of 18 x's. I'm not going to write it out because that's going to take a long time. For number 2, we have 5, which is just a constant, being added to 11 times y. So I'm going to circle the plus 11y, being added to a plus 9. So notice that when I'm circling my terms, I'm also getting the sign that's right in front of that term. That's very, very important because when we go down a little bit onto the back side of this page, we're going to be using subtraction, and the order matters in a subtraction problem. Okay, so I have 2 things circled in red, my constants, and I'm just going to put those together. So ignoring the middle, it just says 5 plus 9, which is 14. And then bringing back that middle piece, it says plus 11y, And there's no other things with a y, so it's just plus 11y. We cannot go any farther with this because there's not a y here. And this means 11 times y. So we can't do any adding until after we've done this multiplication, which we unfortunately cannot do because we don't know what the y is. So we're done. In number 3, 6 times x plus 2 times y. 6 times x. The other one is a 2 times a y, so I'm using a different color. They don't match. There's nothing else in this problem, so we can't do anything. It's just 6x plus 2y. So in order to move on with this problem, if we had x and y, we would multiply first, and then we would add. So until we get x and y, we're stuck and we can't go any farther. All right, skipping 4 and 5, moving on to 6. 6 has 8x squared plus 10x. They do both have an x, but the first term has an x squared, and that is different. The exponent has to be the same. Technically on 10x, it's just a 1 there, not a 2 as the exponent. So this one also just stays the same, 8x squared plus 10x. And until we find out what x is, we're stuck because we can't evaluate the exponent, and then we can't do our multiplication. And until we do that, we're not able to do the addition, which is usually one of the last steps in order of operations. Like terms can also be subtracted, but we have to remember to keep the sign as part of the term. And when we do that, we also need to make sure that we're using integer operations as we combine the terms, meaning positive, negative whole numbers, and 0. That's what integers are. For example here, 6c minus 5c, it's 6 and then minus 5, so we would get 1 and then c. So you're always just adding or subtracting the coefficients and then keeping whatever the variable attached to them both is. So they both have the c, so 13c minus 5c is going to be 7c. Okay, and just in case you don't believe me on that, for example, with the 6c minus the 5c, 6c would mean 6 c's being added. If we take away 5 of those, we just have 1 left, and that's what's really happening there. Okay, all right, couple more examples here. 14x plus 3y minus 8x. So I see 2 things with x's. And I'm not going to do this. I'm going to make sure I include that minus sign because it's attached to the 8x right behind it. Remember, both of these are multiplication. And then I have a plus 3y. I kept the plus with the 3y because they go together. And I don't see anything else we could do there. So what we would do is we would combine these coefficients. 14 minus 8, which is 6, and then attached to the x, plus the 3y because there's nothing we can do there. 16x minus 9 plus 5x. I have 16x. I also have 5x, but remember I'm circling the operation in front of it as well. And then I have 9, but wait, it's minus 9. So make sure you include that when you circle. So now I'm going to take care of the 16 and the 5, adding. That's going to be 21. They are both times x. So it's 21 times x, and then just a minus 9. All right, a few more examples. So in number 7, 11 times a minus 5 times c plus 3 times a. So since I see the 2 with a's, I'm going to circle them both, including that sign in the front, and then I just have one thing multiplying a c, and I'm including that minus 5c all in the circle. 2 things in red can be combined, so 11a plus 3a, add your coefficients. 11 plus 3 is 14 times a minus 5 times c, because that one didn't change at all. Number 8, 16 plus 12 times b minus 7 times b. So I have 16, then I have plus 12b minus 7b, including those operations in my circles to make sure they stay attached to the thing right behind them. And in this one, I see one constant all by itself being added to 12b and then 7b being taken away. So I'm going to take this 12 and this minus 7. It's going to give me a plus 5b. And we can't do this and get 21b because there's no b right here with this 16, which means we're not allowed. They're not like terms. Other way to think about it, this means 5 times b, and we can't do this addition following the order of operations until after we do this multiplication. And unfortunately, we don't know b, so we're not able to do that multiplication at this point. So our final answer is just this. Okay, number 9, 4 times d minus 8 minus 3 times d. So 4d minus 3d, those match, and then we have a minus 8. Subtract your coefficients because there's a subtraction here. 4 minus 3 is 1 times d minus 8. This 1 doesn't need to be written because 1 times anything is that thing. So this is actually the exact same as just d minus 8. In number 12, 18 times r plus 7 times q minus 11 times r plus 13 times q. So my 18r and my minus 11r are going to go together. And then my plus 7q and my plus 13q also go together. So an 18r minus an 11r is 18 minus 11. It's going to be 7, and then still times r. 7 times q and 13 times q being added is going to make 20 times q. And we can't go any farther because this has r, this has q. And we're stuck at the point where we would need to multiply here before we could do the addition in the middle. But we can't multiply because we're not being told the value of the variables. All right, last one of these, and then we'll look at one with some geometry. 4x squared plus 14x squared minus 1x. So while that 1x does have an x, it's missing the squared. So it's a separate type of term, and we cannot combine them. So we'll go ahead and we'll combine the coefficients, 4 and 14, which is 18x squared, and then just minus 1x, or if you want, 18x squared minus x. And we can't do anything else there because of the squared. All right, last one, number 17. Find the perimeter, or at least represent the perimeter. Perimeter means to add all sides. So 3x minus 1 added to 3x plus 8 added to 3x minus 1 added to 2x plus 4. So that is our expression. We could definitely simplify it a little bit. I see all these x terms. 3x plus 3x plus 3x again, and then plus 2x. So take a look there. We have 3x and 3x, which is a total of 6x. Another 3x would make 9x, and then another 2x would make 11x. And then left over, we have the minus 1, the plus 8, the minus 1, and the plus 4. So 8 minus 1 would be 7, minus another 1 would be 6, and then add 4, we'd get 10. So notice here that we combined x's with x's and constants with constants, and we can't go any farther because this means multiply, and you cannot add before you multiply.